Okay, welcome back. We're talking about section 2.3, which is conic sections, specifically parabolas. In this particular video, we're going to derive the equation of a parabola if we're given the focus and directrix. So, in general, conic sections come in 4 different flavors. You learned about circles and ellipses in geometry. A circle is when you cut a cone so that the cut is parallel to the base. An ellipse is when you cut a cone so that the cut is not parallel to the base. A hyperbola is what happens when you actually have 2 cones, and we're going to cut perpendicular to the base. So we're going to cut that right there, and we end up with these really pretty, almost parabola looking things. And then today we're going to talk in class about what happens if you cut a cone so that your cut is parallel to the side of the cone, and that is called a parabola. Okay, so up until this point, we've talked about a parabola as a U-shaped object. But officially, a parabola is actually defined as a set of points that are the same distance from a point and a line. So let's review. We know that a parabola has an axis of symmetry that we called x equals h, and it also has a vertex that happened at hk. And the vertex is the point at which the parabola intersects the axis of symmetry. And of course, that parabola goes on forever. So in this next slide, I'm going to talk a little bit about how we can define a parabola as the set of points that are equidistant from a point and a line. Okay, so to recap some of the parts that we talked about, the axis of symmetry is the line that crosses through both the focus and the vertex. So the vertex right here and the focus right here. And the parabola is reflected across that x-axis. So whatever happens over here also happens in the same way over here. And so the vertex is a certain number of points away from the focus. That's P, we'll say. And then it's that same P length to the directrix below. Okay. So that distance between the focus and the directrix is going to be the same. So if this is 1, 2, 3, 4 units, this is 1, 2, 3, 4 units. And you can see that the distance between any point, any single point you want to pick on the parabola, if you draw a line from that point to the focus and that same point to the directrix, perpendicular to the directrix, you will get the exact same measure. So when we talk about this, we at some point need to put it in an equation. So remember that the vertex is hk, that's important to remember, and our axis of symmetry is x equals h. And so we have these two equations and points that we've talked about before. So what about this focus and directrix? Well, remember what I just said, that the distance between the vertex and the focus is p units long. That's important. And the axis of symmetry crosses through both the focus and the vertex. That is, the x value for both the focus and the vertex are going to be the same. They're going to be h, because that's the axis of symmetry. Now, the height of the focus is going to be k units plus the p length. So our focus is going to happen at h, k plus p. Our directrix is exactly p units below the vertex. And since it's a horizontal line, it's in the form of y equals k minus p units. So k units minus p units gives you y equals your directrix. Let's take a look at the formulas. So y equals x squared is the parent function of a vertical parabola with a vertex at 0, 0, an axis of symmetry at x equals 0. No stretch or shrink, and the vertex is at 0, 0. If we want to transform that, the distance between the focus and the directrix is what helps us find our vertical stretch or compression. So we take 1 over 4 times the distance between the directrix and the focus, and then we still have our x minus h quantity squared, and then plus k. And so in general, our vertex will always be hk. Our focus will still be h because that's also on the axis of symmetry. So our focus is up here. And our y value is going to be k plus p. So if this is our focus, we have p units to go up to get to k plus p. Our directrix is p units below the vertex. So we're going to go k minus p to determine where the directrix is. Go ahead and pause your video, make sure you have all this. And in the meantime, let's do an example. So for this first example, we're going to go ahead and graph it and write the equation for it. So in general, if you have a focus at -2, 3, so we went ahead and graphed that, and a directrix at x equals -1, we can go directly in between the focus and the directrix to find the vertex. And if we didn't have a graph, we could do that algebraically by finding the average. 3 plus -1 divided by 2 is going to be 1. So our vertex is at -2, 1. Our equation, we will need not just h and k, but also p. So we're going to go ahead and count here 1, 2 units. So the vertex is 1, 2 units away from the focus or the directrix, so p equals 2. And we can also confirm that algebraically because the same distance 3 to 1 is 2 and 1 to -1 is also 2. So to write the function, we are just going to plug in the values for p, h, and k. So y equals 1 over 4 times 2, 4 times p, which is 2, times x minus -2, quantity squared plus 1. So simplify, y equals 1 over 8, x plus 2, quantity squared plus 1. Now to graph this, we're going to pick a table of values. I'm going to try to start with always the vertex, so we're going to start at -2, 1. And then I'm going to try to pick values for x that make when I divide by 8 not so awful. So if I pick 0 here, so if x equals 0, 0 plus 2 is 2, squared is 4, divide by 8 is a half, plus 1 is 1.5. And if before I graph, I put my axis of symmetry through my vertex and my focus, I can go ahead and graph 0, 1.5. Sorry, that should be 1.5. 0, 1.5. And then I can reflect that across the axis of symmetry, 1, 2, 1, 2, and 4, -4, 1.5 should also be on the graph, and I can algebraically check that. Then I'm going to go ahead and put in something that'll give me 16 here, so 4. So if x equals 2, 2 plus 2 is 4, squared is 16, divided by 8 is 2, plus 1 is 3. So if 2, 3 is on the graph, and I count across 1, 2, 3, 4, 1, 2, 3, 4, then -6 should also be on the graph, and you can algebraically check that -6 will equal 3 when put in this equation. And then finally, if I put 6 in for x, I get 6 plus 2 is 8, squared is 64, divided by 8 is 8, plus 1 is 9. So 6, 9 is another point on the graph. And I'm going to go ahead and count all the way over, and I end up with -10, which I can double check algebraically. So -10, 9 is also on the graph. I'm going to finish it off by go ahead and sketching this parabola so it looks nice and neat, and there we go. Okay, so let's try this problem. Go ahead and pause the video if you want to take a look and try to graph the focus and directrix. Okay, welcome back. So we graph our 1, -1, and our y equals 5. And we should notice right away that the directrix is above the focus. This means that our graph is going to point down, or that a is less than 0, right? Negative, basically. So to find the vertex, again, I can algebraically check, or I can count 1, 2, 3, 4, 5, 6. So 1, 2, 3, and there is my vertex. And then I can graph my axis of symmetry if I want to. So I have my vertex and I have my axis of symmetry. And now I'm going to use the fact that my vertex is at 1, 2 to determine what my p-value is. So 1, 2, 3, 1, 2, 3. So I'm halfway between, so my p should be 3. If you're not halfway between, then your vertex is not correct. You need to be exactly halfway between. So write the function, which again, if you haven't made note of it, make sure that you have this function in your notes starred, highlighted, and blinky lights. So y equals 1 over 4 times p, which is 3, times the quantity x minus 1 squared plus k. So when you simplify, you have y over 12, x minus 1 squared plus 2. So in order to create values, always, always, always start with your vertex, so 1, 2. And I notice right away, since I'm dividing by negative 12 because it opens down, I forgot the negative earlier. I had set it down here, but it should be included here. I'm going to try to pick some values that make it a little bit easier to graph. And you can do that using your graphing calculator, or you can kind of feel your way around the problem and see what's going to fit. So if I look at this, if I make this negative 2, negative 2 minus 1 is negative 3, squared is 9. 9 divided by 12, or negative 9 divided by 12 is 3/4. So negative 3/4 plus 2 is 1 1/4. So 1.25. So if I graph negative 2, 1.25, graphing somewhere here. And if I use 1, 2, 3, 1, 2, 3 symmetry, that should be another point, and I can check that on my graph here by putting 4 in and running through the algebra, and you'll find that 1.5 is your y value. Okay, the next value I can check, I'm going to look at negative 5, and when I put in negative 5, I get out negative 1. So negative 5, negative 1 goes right here, and if I go over 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, then 7, negative 1 should also work. And when you put in 7 into this calculation, you do end up with negative 1, and that gives you a nice parabola to graph. So we're going to go this way, and then we go this way. And we notice that our vertex is intact right here, and our reflection is intact with the negative, and it's been compressed by 1/12. Okay, so at this point, we've only talked about vertical parabolas. We have not talked about horizontal parabolas. Now, horizontal parabolas have exactly the same parts as vertical parabolas, only instead of the y's depending on the x's, now the x's are going to depend on the y's. So we still have our same points. Our vertex is still at HK. But now our axis of symmetry is a horizontal line, so it's y equals, and it's going to have the height of k, so y equals k. We are still p units away from the focus, so the vertex is still going to have the same k value, but this time our h value is going to have p added to it to get to our focus. So our focus is going to have the point h plus p, k. Okay, our directrix is going to be p units to the left of the vertex. That is, we're going to take the value of x, h, and we're going to subtract p units. So our directrix, since it's a vertical line, is going to be x equals h minus p. And so here are the 4 basic expressions for each of the parts of the parabola. In general, a horizontal parabola is in terms of y, that is, it's x equals y squared. You still have a vertex at 0, 0. The general form, you'll notice, our a is still here in the form of 1 over 4p. But our x's and our y's have switched places. So our y, which used to be outside, is now inside with the k. And our x is now outside with our h. Just as before, our vertex will remain the same, hk. But in the case of a horizontal parabola, our focus is dependent, going to change the x value. So it's going to be h plus pk. And our directrix is going to be x equals h minus p. Okay, go ahead, pause the video and read the problem, graph the focus in directrix. Okay, so you should have graphed -6, 2, and then the directrix x equals 2 is where x is always 2, and that's the vertical line at x equals 2. To identify the vertex, we want the point that's exactly halfway between. So if we count 1, 2, 3, 4, 5, 6, 7, 8, half of that is 4. 1, 2, 3, 4. So we're going to plot this point here, which is -2, 2. So our vertex is -2, 2. And the distance between the two is going to be our p-value. So 1, 2, 3, 4, 1, 2, 3, 4. Good, it's exactly the same. And when I'm looking at my equation, I notice that my directrix is to the right of the focus. So that means my parabola is going to look something like this. And when parabolas face to the left, when horizontal parabolas face to the left, a similar thing is happening as when vertical parabolas face down. And that is that this value here is going to be negative. So you're going to make what used to be a negative. So that is, we're going to write x equals -1 over 4 times 4 times y minus k, k is 2, quantity squared, plus h, h is -2. So when I simplify, I have x equals -1/16, quantity y minus 2 squared minus 2. Okay, so I'm going to create a table of values just like I always do, but in my table of values here, the vertex is -2, 2, but my equation is in terms of y. So I'm going to pick some y values that are going to make my x values a little bit easier to graph. So if I pick y equals 4, 4 minus 2 is 2, squared is 4, divided by 16 is -1/4, minus 2 is -2 1/4. And if I look at my axis of symmetry that goes directly through both my vertex and my focus, and I graph -2 1/4, 4, and go 1, 2, 1, 2, and if y is 0, I should also get -2 1/4. And so I can try that out. So if y is 0, 0 minus 2 is -2, squared is 4, divided by -16 is -1/4 minus 2. Okay, so -2.25. Let's pick another value. So if I pick 6, then 6 minus 2 is 4, squared is 16, so -1 minus 2 is -3. So -3, 6 should also be on the grid, and by symmetry, 1, 2, 3, 4, 1, 2, 3, 4, -2 should also give me x value of -3. So when I pick -2 for y, -2 minus 2 is -4, squared 16 divided by 16, -1 minus 2 is -3. And then if I pick y equals 10, so y equals 10, 10 minus 2 is 8, squared is 64, divided by -16 is -4, minus 2 is -6. So -6, 10 is a point on the graph, and if I go by symmetry, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If I put -6 in, I should get -6 out. So -6 minus 2 is -8 squared. 64 divided by 16, -4 minus 2 is -6. And so I can go ahead and graph that parabola just like this. Okay, so we don't always have to graph the parabola. We can also write an equation just given the focus in Directrix. But in order to do that, we're going to want to at least sketch where we are. So if I have a Directrix at x equals -2, so x equals -2 means my Directrix is going to be somewhere in this vicinity. So x equals -2. And my focus is at 1/4, 2. So looking somewhere here. So 1/4, 2. I know my axis of symmetry is going to go right through here. So my axis of symmetry is going to be at y equals 2 because that's the y value of the focus. So I know immediately to identify the vertex, the y value of my vertex is going to have to be 2. So I at least know half of the vertex is going to be 2 because it has to lay on this line of symmetry. And I also know that it's halfway between 1/4 and -2. So I can go ahead and calculate by doing -2 plus 1/4 and divide that by 2. And so when I put that in the calculator, I end up with -2 plus 1/4 is -7/4 divided by 2 is -7/8. So my x value for my vertex is -7/8. In order to be able to write the function, I also need a p-value. And so here, if I know this is at -2, and I know my vertex has to be at -7/8, 2, then I know that this is 1 1/8 away, or 9/8 away. So p equals 9/8. And so I can go ahead and put that in my parabola. So I know that the parabola is going to go in this direction, so it's going to be positive. So it's going to be y equals 1/4 times p, remember p is 9/8, times y minus k, which is 2, k is 2, plus h, which is -7/8. And I can go ahead and simplify this. So 1/4 times 9/8, so this divides out to 2. So x equals 1/9 times y minus 2 squared minus 7/8. Oops, 7/8. And then when you divide by a fraction, you're really multiplying by its reciprocal. So x equals 2/9 over y minus 2 quantity squared minus 7/8. And we're going to do a couple more of these in class. So if you're not 100% sure about it, just take a moment and we'll work some more out in class. Go ahead and watch some more examples videos if you have any questions. Otherwise, complete the 2.3 Conic Sections reflection. Up next is the Solving Quadratics by Graphing video. Thank you so much for listening. Have a great day.